Okay, let us start the class. So we have progressed into the second part of the course where we have looked at three different biometrics in some level of detail. We have looked at fingerprint recognition systems, and I clearly told you that it's a very inexpensive biometric, which is fairly universal in the sense that it is used by police and law enforcement agencies all around the world, even today. And it has wide applications everywhere, simply because of the fact that it is not rocket science. It's very simple biometric, simple image processing, where you take a fingerprint, you do some image processing operations of pre-processing, edge detection, and then you extract some features or the minutiae and so on. Then, we saw fingerprint, which is a physiological biometric. We also saw hand biometric, hand recognition system. In some places, it's also called palm print. Palm is a little different from the hand, but the concept and the underlying concept is the same for both. So in the hand recognition, we do not use the fingers. We use the image of the finger, yes, the hand, no, but not the way the minutiae are there in the fingerprint. In the hand, what we do is we take our hand, we take an impression or an outline of the hand, and that outline of the hand we make measurements of those vantage points or salient points in that hand. So the tip of one finger to the end of to the root of that finger, as the every finger, two widths are taken, and so on, and you get a vector which has 10 plus 5, 16 values in that vector, in that feature vector, and based on that you do a comparison. But so the logic is slightly different, even though it is based on image processing. So after two physiological biometrics, we saw a voice or a speech recognition system. I told you they are one and the same. And this is a behavioral biometric, something that depends upon the behavior. Today we are going to see another behavioral biometric, that is handwritten signature. Now, I already told you offhand, given you a heads up that all behavioral biometrics are not very having very good FAR or FRR. I'm sure you remember. Please remember, FAR is false accept rate, FRR is false reject rate. So all behavioral biometrics slightly on the high side. They have high FAR and high FRR, false accept and false reject. Definitely all the physiological biometrics which are based on your body, the human body, and some aspects have a better FAR and FRR. But nevertheless, we use these because they are inexpensive, and some applications prefer to use these kind of behavioral biometrics, like speech recognition systems. You see, speech processing, certain applications, speech processing is even today preferred for obvious reasons, even though the FAR and the FRR are slightly high. It is the same case with this behavioral biometric, namely the handwritten signature verification. So, signature verification, mind you, the signature is just an image. Please understand that a signature is just like an image, just like if you are doing a fingerprint, you put your signature, and that signature image is taken and it is converted into some patterns or points. That is known as a static or an offline signature verification. You are giving a signature, that image is taken, and that image is like a fingerprint. I'll show you that slide. That image is taken. See what is happening over here. There is an image, and from this image, structural features are extracted, and these structural features are converted into some kind of a vector or some kind of a code or something like that, and this code is compared to others. Exactly like the fingerprint. The only difference is in the fingerprint we are looking for minutiae or ridges or features. Here we take the fingerprint and we convert the fingerprint based on some structural features. Now, wherever you don't have a structural feature, you can actually fill it with some sort of statistical value. It is like telling, you have a puzzle with 9 squares. 7 squares are filled. 2 squares are not filled. Now what do? You need to fill the other 2 squares. The easiest way is to have some statistical value computed from the other seven squares that are filled. So that kind of statistical values may also be added into that feature vector. But generally speaking, the fingerprint is converted into a feature vector where the structural features are converted. Now you can see the structural features. There's an upward arc, an upward cusp, an upward loop, downward arc, downward loop, and so on. And this value is computed, and you compare with the next time you give the thing. You can not only give the position, you can give the orientation, you can give the angle, and also 3 different attributes also you can take for the feature vector. You can use some sort of mathematical or statistical model like hidden Markov models also to to do a more in-depth analysis to get you some sort of number or value. But this is more than enough. When you have a signature, you take the statistical features, you extract them, and you extract the statistical features and get the number, the position, the orientation, the angle, convert that into a feature vector. You are having it, and the next time you just need to compare. Of course, you can add a little more complication by adding some sort of machine learning technique or deep learning technique. But today the common signature verification systems like IBM has a very popular online signature verification. CyberSign PenOp is another company that is doing signature. CIC, Communication Intelligence Corporation, is doing this. These kind of signatures, especially in US and all, when you get a FedEx parcel and all, you can just use this kind of, one of these things are used, either it is CyberSign or CIC. But here, the logic is slightly different. Here, we are giving a signature using an electronic pen into the tablet, but it is not the structural features of that signature that is taken. In the static mode, we are taking the structural features of the signature. If you say this is something like YJEC or something, but this YJEC, there is an upward arch, there are 2 downward arches, there is 1 downward loop, there are 4 upward cusps. This is a static signature where you are putting a signature and taking the image, that image you are extracting the structural features. This is static. But dynamic, the logic is slightly different. You are giving your signature into a tablet, and that image is stored in the tablet. But what happens in that is that it doesn't take the structural features, rather it does take some structural features, but rather it looks into many other features in addition to the structural features for in terms of making the feature vector. So from the electronic pen you are giving, it looks at several features. It looks at width, height, duration, how the speed of how you are putting the signature on the tablet, the pressure, the curvature, the style. So many things are converted in this kind of the electronic pen. So it does use structural features, but the logic is different. It looks at how you are pressing the pen, the curvature, the speed, the velocity, the pressure. Then different coordinate axes are there, like X position, Y position, speed, curvature, pressure, orientation, duration, height, width, and then we get what is known as a feature vector, and that logic is slightly different from the other static system. This is a dynamic system. Now, as mentioned, in the dynamic system, the movement of the pen during the signing process is more important than the static image of the signature. Yes, the static image of the signature is there, important, and the structural features are important, but we are looking at more other aspects of the movement of the pen, how you are pressing the pen, the pressure, the sound the pen makes, the speed, the curvature, the width, the height, and all those. From there you get a much better feature vector, and it is estimated that we can have 100+ features in the feature vector. As also, we also need at least 6 genuine signatures of the same person to be able to train the system. Because obviously when all of us are signing, there are slight variations may happen here and there. So 6 different signatures are needed to complete the basic knowledge base for the dynamic handwriting system, and that is very important. Only then it gets a fair view of what your signature is and what your coordinates are. So 6 signatures are needed. Otherwise, the same thing we can also use. We can do the same operations like image processing. You can clean up the electronic signature which you have made. You can smooth it. You can do pre-processing. You can clean it up. You can remove the noise. You can also use, in addition to that feature vector, you can use a similarity measure. Using a regression model also is possible. That is to complicate things. If you want to have a more accurate number or a score, you can have what is known as a regression model along with this feature vector. So to cut the long story short, there are 2 types of signature verification systems. The first is static system or offline system, where we are signing in a paper, and that image is taken, scanned, and that scanned image is converted into a feature vector by extracting the structural features of this thing, and we can wherever there is a gap, we can do some statistical prediction and fill in the missing values, removing the noise, and that image is that becomes the feature vector. We can use hidden Markov models or some mathematical technique to play with it also. But the more popular method is the dynamic or online signature, where you are signing with an electronic pen onto a digitizing tablet. Now here, not only the signature and the image and the structural features are important, but how you hold the pen, how you press the pen, the pressure with which you hold, the width of your signature, the length, the height of your signature, the X position, Y position, and so many other factors which we convert into a 100 feature vector. And that feature vector we do the image processing application, pre-processing, cleaning up, smoothing, and so on, and then we can even use a regression model to predict the same. Now, as mentioned in the earlier class, this is a behavioral biometric. Obviously, there are issues when we are using behavioral biometrics. I have already told you the FAR, the false accept rate is high, FRR, false reject rate is high. That will be always there, because you also know, you take your signature, the very simple logic. You look at your signature. If you have your old passport, you look at the signature on the old passport and the new passport, maybe 7 or 10 years back, you will find that the signature changes. Over age, your signature changes. And another issue is even your tiredness, your fatigue rate, your emotional disposition also influences the signature. You're very angry and all, your signature will be erratic. Similarly, you're emotional, you're angry, you're very tired, extremely tired. The signature slightly wobbles when you're tired. Now, I know, you give me 100 answer sheets to sign. It's better to sign everything in one go. After 30, 40 signatures, the signature starts wobbling because you feel tired. So those issues are there with the signature recognition system. And like any behavioral biometric, the FAR, the false accept rate, is not very low. It is pretty high. FRR, false reject rate, is also pretty high, just like speech and recognition. I would think that signature recognition systems will be having a better FAR and FRR compared to voice and speech. So that is all for today. Now, you can stop the recording, please.